All right, hey y'all. Hope y'all had a good Thanksgiving break. I will not be at school Tuesday and possibly Wednesday and Friday as well. Not feeling well after the break, and just gonna recover from that. Don't want to make sure I don't have COVID. All right, so here's an email I sent y'all last night, and so just some notes. So what I'm going to do is Tuesday, this is the video for the quick lesson on some notes that we would have done, just one of the pages. And then I want you to complete 5.2 quiz on Schoology. Do this in class, and you can work on the 5.3 homework in class. So should get all this done. And then even if you wanted to, there's a Wednesday activity in Schoology. So Chapter 5, Probability in Schoology, Wednesday 12-2 assignment. So if you want to do that as well, you can start it because you're going to do this activity on Wednesday or by Wednesday, and I'm going to go over it. I'm going to make another YouTube video going over that, and we'll do something similar on Friday, kind of like as a review. And then next Tuesday, we are going to have a test on probability. All right. So let's see. So here is the notes on, the second to last notes page on our notes packet, probability. The main thing I want to talk to you about is conditional probabilities and independent events. So how do we tell if things are independent? All right. So what we would have done if I was in class is kind of remember our class data for the can you do the evil eyebrow or the taco tongue. So let's just use this imaginary data here. So this is our class, 30 people, whatever. All right, so find the probability. So this is kind of like a review of before the break. Find the probability that you can be yes taco tongue or yes evil eyebrow. So probability that you are yes taco tongue and yes evil eyebrow. So there's 20 taco tongues, 18 evil eyebrows. So you got 20 over 30 plus 18 over 30. But you've got like the Venn diagram, there's some overlap, and that overlap is that 15. So you have to subtract 15 from those other two, and you get a total of 23 over 30. So that is like an or statement. An or like a U is a union, so everything's combined. All the evil eyebrows, all the taco tongues, everybody combined. Basically, these 7 people are the ones not in it. All right. Number 3, so we're going to talk about conditional. So given that the person selected is a yes evil eyebrow, what is the probability that they are a yes taco tongue? Write it as a fraction, a decimal, and a percent. All right. So given that the person selected is yes evil eyebrow. So typically on these, they like tell you like, if this person is evil eyebrow, then what's the probability of this given this scenario? So the given evil eyebrow is only in this evil eyebrow universe. So only in this little column here of 18 people. How many of those, what's the probability of those people that they were yes taco tongue? So it was 15 out of 18. So it's conditional because the condition is we only care about this yes evil eyebrow people. So it's a condition. So 15 out of 18, 83%. Sometimes you can see it written like this with this bar. Where's it better? So like P, and then you got your parentheses, something, bar, something. So given the bar, after the bar is the condition. So probability that you're a yes taco tongue given that you are yes for evil eyebrow. So given we're in the evil eyebrow category, which is 18, how many were yes taco tongue? So 15. Okay. All right. So given that you're a person who selected no as evil eyebrow, what's the probability that they are yes taco tongue? All right, so here it is written out in this little form. Probability that you're yes taco tongue given that you are no evil eyebrow. All right. So you look at your table. How many people were no evil eyebrow? That was 12. There's 12 people who were no evil eyebrow. That's our condition. So I put 12. What's the probability that they're yes taco tongue? That's 5 out of 12. So this little notation here is given no evil eyebrow. So given that there's 12 people, 5 of those can do taco tongue. So 41%. All right, so that's conditional. So we even talked about conditional in geometry, and you've seen conditional before. So conditional probability is just this notation sometimes is the mix-up. And so given that you are in the evil eyebrow, so only evil eyebrow people, how many people were yes? So 15 out of 18, 5 out of 12. All right, definition. So here's our other thing, main thing here. Definition. Two events are independent if knowing whether or not one event occurred does not change the probability that the other event will occur. All right, independent. If I know that something's going to happen, it doesn't change the odds of the other thing happening. So let me give you like a super basic definition. Flipping a coin heads and rolling a dice, two are independent. Because if I flip a coin heads, the dice doesn't care whether the coin was flipped heads or tails. So if I flip a coin heads, there's still a 1 in 6 chance that I roll a 5 on my dice. So those events are independent. Okay, independent. Like, let's say that I am independent from, like, I don't know, from like your family. My family's independent from your family. So the probability of you choosing to go out to eat last night was not going to affect the probability that my family went out to eat. Those two events are independent. Okay? Events are dependent. So if it's dependent, that means that basically that, like, if I know that something occurred, then this other thing might change it. So, like, let's take it like this. Like on taxes, my daughter is listed as a dependent because she's dependent on what I do. So if I went out to eat last night, my daughter would also probably have gone out to eat. The odds of her going out to eat if I went out to eat drastically changed. So that would be dependent, okay? So they're independent if the odds don't change between two events. They're dependent if they do change. All right, so number 5. Are the events yes taco tongue and yes evil eyebrow independent? So if I am a yes taco tongue, does that affect me being a yes evil eyebrow? All right, so we look at, the way we can look at it is like we look at these we look at these conditionals on number 3 and 4. So given I was yes evil eyebrow, what was the probability of me being a yes taco tongue? It was 83%. Okay, what if I was a no evil eyebrow and a yes taco tongue? It was 41%. So those odds changed. So the definition says the probabilities don't change if they're independent, but these odds changed. So that means that this is not independent. People who have evil eyebrow are more likely to do taco tongue. All right, let's look at another example. Okay, so here is some more data on that same thing, same general thing here. All right, so what they did was find the probability of the following. So probability that you are a yes taco tongue. So that was 480 people out of 600. So yes taco tongue, 480 out of 600. Trying to see something. trying to make an arrow. Nope, not gonna let me do it. Alright. Okay, so probability that you are a yes taco tongue would be 80% is what they found. Alright. B, find the probability that you are a yes, you can do taco tongue, given, so the bar there, given that you are a yes for evil eyebrow. Alright, so the given category is all the people in the evil eyebrow. So of the people who can do evil eyebrow, so of these 200 people who can do evil eyebrow, how many of them are also yes on taco tongue? So that was 180 out of 200, which is 90%, 0.9, 90%. All right, C, what's the probability that you can do taco tongue given, so the bar again, given that no evil eyebrow? All right, so I'm in the world of being a no for evil eyebrow. So in the world of no evil eyebrow is 400 people. And in that world, 300 of those 400 people can, yes, do a taco tongue, which is 75%. All right. So, are the events yes taco tongue and yes evil eyebrow independent? So, do the odds change from one of those events to the other? Like, if I knew something about, like, if I knew you were a yes evil eyebrow, would that change if you could be a taco tongue or not? All right, so here's our original 80%. Like, if nothing changes, I should be 80%. Okay, but when I was yes on evil eyebrow, all of a sudden my taco tongue percentage went up to 90%. So what that means is, if you told me that someone was in the evil eyebrow category for yes, then I could guess that they had a higher percent chance of yes taco tongue. If they were a no evil eyebrow, then I would know that they had a lesser chance of being a yes taco tongue. So are these events independent? Did the probability from the normal one to here change or not? And so it did change. So are they independent? It would be no, they're not independent. They are dependent events. Okay, we can do some more practice, especially when I'm back, but like the main thing, if they're independent, the odds should not change. But what we saw here is, if I know that you're a yes for evil eyebrow, I can say that you're more likely to be able to do taco tongue, 90% compared to 80%. If I know that you're a no evil eyebrow, I see that you only have a 75% chance now of being yes. So those are not independent. All right, so fill in the table as if the events were independent. So if they are independent, so 480 out of 600 is 80%. And that means 20% can't do the taco tongue. So yes, taco tongue is 80%. No, taco tongue's 20%. So if these are independent, what that means is, whether or not they're yes or no evil eyebrow, they should still be 80%, 80%, 20%, 20%. So 80-20, 80-20, 80-20. Nothing changed for the yes taco tongue, whether I was yes evil eyebrow or no evil eyebrow. It still stayed 80-20, 80-20. Okay? So if they are independent, these percentages are still like the normal. So we look at it like this. Like mathematically, we have like a little formula, and it's with these conditionals. So conditionals and independent go hand in hand. So are these events independent? So probability that yes, you're a taco tongue is 80%. All right. So what's the probability that yes, you're a taco tongue, given that you're a yes for evil eyebrow? So out of the evil eyebrows, out of 200, there was 160, which is 80%. Okay. Find the probability that you're a yes taco tongue, given that you're in the no evil eyebrow category. So the way we set it up was 80-20, so it was 320 over 400, 80%. So what you can see is when these events are independent, these conditional probabilities are equal to one another. These are both still 80% here. 80, 80, 80. Nothing changed. Just because I know that you're a yes evil eyebrow, I still think you're the same probability. 80%, 80%. Nothing changed. But up here, these were not independent. These were dependent. Not independent. Dependent. Same thing. So if I knew that you were a yes evil eyebrow, your odds went up to 90%. If you were a no, you went down to 75. So these were different, these were the same, and so these are independent. Like you being a yes on one and a yes on the other have no effect on it. But this data table showed that, hey, they do have a similarity. So maybe, like genetics wise, the odds of you doing an evil eyebrow are similar with taco tongue, and so the odds went up if you were a yes and yes. So maybe there's something there genetically, maybe there's not. So if they're dependent, the odds are different. If they're independent, those odds are the same. So here it is written out in like notation form. And so if we say that the events are independent, the original probability, that 80%, is equal to the probability of that event given this other event. And that's also equal to the probability of the event given the opposite one. So, like, the probability of getting the rolling a 5 on a dice is equal to the probability of rolling a 5 given that you rolled a heads, which is equal to the probability of rolling a 5 given that you flipped a coin tails. So like those would be independent in that scenario. So if all these odds are the same, so like this one right here, if they're all still 80%, if they all stayed the same, then yes, they are independent. If they changed, so if those conditionals changed at all, then they are dependent or not independent. Okay, so kind of a big point here, like, are they independent or dependent? So independent is when the conditionals are the same, and they're dependent if the conditionals of those two events changed. So if I know that Ellie went out to eat last night at Chick-fil-A, then the odds of Mr. Hamilton going out to Chick-fil-A are probably really high. They changed from just a normal odds. But the probability of Mr. Hamilton going out to eat last night and the odds of like one of y'all going out to eat last night, like those don't change. Your odds don't change because I went out to eat. Like we have no effect on each other. Okay, so these conditional probabilities, if they're the same, they're independent. Alright, so let's just look at this check your understanding and then we're gonna be done. So check your understanding here. Here's a table of 100 mothers selected in the years 1976, 1994, and 2014. Alright, and the question that they asked them was, how many children do you want to have? 1, 2, 3, or 4 or more. And you can see the spread. Alright. So, find the probability that event C, so they said C is have 4 or more children. So find the probability that you want 4 or more children given that the year is 1976. So given 1976, so given this little column here, given 1976, which is 100 people, how many of those people also wanted four of those mothers that year wanted four or more children? So 40 out of 100 wanted four or more, so 40%. So given the mother was surveyed in 1976, there is a 40% probability that she had four or more children. All right, let's do the other one. Given that they chose a mother not in 1976, so like 1994, 2014, what's the probability that those mothers wanted four or more children? So give that probability. So out of these people, how many wanted four or more children? So there was 200 total mothers, and 13 plus 13 is 26. So 26 out of 200 mothers wanted four or more children. That is 13%. So 40% of women in 1976 wanted four or more, and then outside of 1976, only 13% wanted four or more children. So are the events people surveyed in 1976 and the event having four or more children independent? So are those independent from each other? So if they're independent, that means knowing that it's not the year. If I know the year is 1976, does that increase or decrease my odds of having four or more children? All right, so if I know the year is 1976, there's a 40% chance that those ladies wanted four or more children. If I know that it's not 1976, there's a 13% chance of having four or more children. So are the events independent? Are those probabilities the same whether or not it's 1976? No, they're not. They're not equal. So these events are dependent. So it says, no, the mothers in 1976 are more likely to have four or more children. Those two conditional probabilities were not equal. So these two events are not independent. So knowing that it's 2014, the odds of people having four or more children went down, basically. Like, the number of children you have depends upon what year it is in America. Like, in the 70s, they were having more children than in the 2000s, okay? So are the events independent? So what you do is you look at the conditional probabilities, and if those two, like having one event with it, that same event with the opposite one there, if those two probabilities are different, then they're not independent. If those two probabilities are the same, then they are independent. So it's kind of weird. It takes some practice. So you need to work on it. You need to try out some assignments, try out the homework. We're going to do some worksheets on it. Let me see. I'm trying to look at the homework. We're going to do some worksheets on it. We're going to try it out. And we're going to get on it. So on Wednesday and Friday, the little assignments we're going to do are going to have more problems with that. But just getting the ideas of, are these events independent or not? So if they're independent, knowing one thing doesn't affect the other. So the odds still stayed the same in the conditionals. Okay. So conditional probabilities. All right. Hope y'all have a good day. I will see y'all soon. And if not, I'll be seeing you